guys, how are ya? So today we're actually jumping back to section 2.6. Now I know that we've been working on systems of equations, and we are actually going to get into dealing with systems of inequalities. But in order to do that, we need to jump back and review linear inequalities. Now linear inequalities in two variables are very similar to linear equations. Okay, but a linear inequality in two variables is an inequality. So it means it's going to have an inequality symbol. The greater than, less than, or equal to, greater than, or equal to symbols. And they can be written in four different ways. Now, using symbolic notation or standard form, I can write it as ax plus by is less than c. Or, if I use numbers, the a would just be my number 2 plus 3y is less than, 5. So that's a linear inequality in two variables. Okay? Be very careful, it's not a system. A system would have two different inequalities. Alright, it could also be 2x plus 3y is less than or equal to 5. But then we can also use greater than. So 2x plus 3y is greater than 5. And we could also say 2x plus 3y is greater than or equal to 5. The inequality symbol, the symbol with the less than or equal to, less than or equal to, helps me when I'm graphing these, because if it's less than and it's a graph, the line would be dotted. And if it's less than or equal to, then the line would be a solid line. So let's look at an example of how we would graph a system. Before we do that, let's actually look and see if we can determine if something's a solution. So an ordered pair, xy, is a solution of a linear inequality if when we plug the number in, it makes the inequality true. So on your paper, I gave you two examples. We're going to do one together, and I'm going to have you try one. Is 4, -1 a solution to this inequality? So you know that 4 is your x, -1 is your y. You plug it directly into the equation. So 2 times 4 plus 3 times -1 greater than or equal to 5. Let's see if that works out to be true. We get 8 minus 3. Is 8 minus 3, which is 5, is it greater than or equal to 5? Is the inequality true? It is. So that is one of the solutions to an inequality. But an inequality can have many solutions. Different from an equation that would have just one solution, an inequality can have many. All right, now you try. So I gave you one to try. You can pause the movie at this point and then turn it back on to check and make sure you're right. Is 0, 1 a solution to this inequality? Okay, so you plug in, these are your x and your y. So you plug in your x of 0, you plug in your y of 1. Is it greater than or equal to 5? 0 plus 3 is 3. Is that greater than or equal to 5? It is not, so it is not a solution to the inequality. Okay? All right, so that's one thing I could ask you about inequalities. But again, we want you to get an understanding that it has just many solutions. Now, how do we graph it? All right, so here is an example. We're going to graph y is less than 2x minus 3. The first thing that you want to do is you want to graph the line y equals 2x minus 3. You want to look at the inequality symbol. Since it's just less than, that means that my line is going to be a dotted line. All right, so I go to my y-intercept of -3 and I put a point. And then my slope is 2, and the line is rising from left to right. So we're going to go up 2 over 1, and then up 2 and over 1. As I said, since it's less than and not less than and equal to, we're going to make a dotted line through those points. We're going to do our best. Okay, but when we're graphing an inequality, and I told you that there are multiple solutions, what we also do when we graph linear inequalities is we have shaded areas. Okay, we're going to be shading an area that would give me all of the solutions to this equation. In order to find the shaded area, you pick a test point. Okay? You pick a test point that is not on this line. The easiest test point to use is going to be 0, 0, as long as it's not on the line. So I take the test point of 0, 0, and I plug it into the inequality. So 0 is less than 2 times 0 minus 3. So then I get 0 is less than negative 3. If the inequality is true, then you shade wherever that point is. If the inequality is not true, is 0 less than negative 3? It is not, so it's not true. That means that 0, 0 is not a solution, so it therefore cannot be in the shaded region. So I can't shade above the graph, I need to shade below the graph. Okay, so let me review that again. You take a test point. I said 0, 0, as long as it's not on the line, is the easiest one to use. You plug it into the inequality. If it makes the inequality true, then that means that point is in the shaded region. If it makes the inequality not true, then that point cannot be in the shaded region, so you'd have to shade on the other side of the line. Okay? All right, let's do another one. 2x minus 5y is greater than or equal to 10. Okay? So first, we're going to graph the line. Now in this case, I'm going to use the intercepts because it is in standard form. And we've talked about using the intercepts when it's in standard form, that's just a nice, easy way to graph it. So using the intercepts, we're going to find the x-intercept and the y-intercept. We're going to let x and y both be 0. I called it the cover-up method, remember? Okay, so if x is 0, we got negative 5y is greater than or equal to 10, so we divide by negative 5, and we're going to get negative 2. All right, same thing. If we let y be 0, this gets put away, so then x is going to be divided by 2, so x is going to be 5. Again, if you're not comfortable with this, you can always put the line in y equals mx plus b. All right, so now we take those 2 points and we plot them. X is 0, y is negative 2, so there's my y-intercept, and my x-intercept is 5, 0, so right there. Now, since the inequality is greater than or equal to, that means that the line is a solid line, so I'm going to give myself a solid line, okay? All right, so now we're going to use a test point for our shading. So I'd like you guys to go ahead and do that. What's the best test point for us to use? Well, the best test point for us to use is, are you saying it? 0, 0, because it's not on the line, okay? So I'm going to take the test point of 0, 0. I'm going to plug it in to the inequality. So 2 times 0 minus 5 times 0, is that greater than or equal to 10? Well, we've got 0 minus 0. Is 0 minus 0, is that greater than or equal to 10? Is 0 greater than or equal to 10? No, it's not. So that means that that is not a solution to the inequality. So 0, 0 cannot be in the shaded region. So that means we have to shade on the other side of the line. So my shading would be this. Now guys, the big thing here is for you to recognize is that means that every single point on this side of the line is a solution to that inequality. So for example, this point right here, 3, negative 3, that's a solution to this inequality. 6, negative 3, 3, negative 6. So every point that is in the shaded region is a solution to this inequality. So it has an infinite number of solutions, okay? All right, so let's keep going. Let's look at our next example. It's a real life example, and I've got it for you. You have relatives, they're living in both the US and in Mexico, okay? And you're given a prepaid phone card worth $50. Calls within the US cost 16 per minute, and calls to Mexico cost 44 per minute. Write a linear inequality in 2 variables to represent the number of minutes you can use on the calls within the US and for calls to Mexico. All right, so we're going to let X be our US calls, the minutes, okay? And we're going to let Y be our Mexico calls, okay? So if we know that our phone card maxes out at $50, that means that between the 2 types of calls, they have to be less than or equal to $50, okay? So we're going to say that 0.16x plus 0.44y is less than or equal to $50, okay? All right, so then it says solve it. Let's look at it in the next part of this particular equation. Solving the equation. That word doesn't want to work for me. Graph the inequality and find 3 possible solutions to the context in real life. Okay, so what I would like you guys to do is I'd like you guys to go ahead and graph it, okay? Graph the inequality. I would think at this point the best way to do that would be using the intercepts. So why don't you go ahead and graph the line and let's see what happens, okay? Press pause and go ahead and graph it. Okay, so since the equation was in standard form, I actually went ahead and used the intercepts. And I did round slightly. I let x be 0 and I got approximately 114. I think I got 113 point something. And x is 0, y is 313. Y is 0, x is 313. And again, I rounded it. I think I got 312.5. And I only did that just for my graph because I kind of want you to see what's going on here. So my y-intercept is about 114, so somewhere up here. And my x-intercept is about 313, so right about here. And then I graphed my line. It was less than or equal to, so I've got that going on. Now, I need to see where all the solutions lie, so I'm going to use my test point of 0, 0. All right, this one should be easy for us. We take our test point of 0, 0, and we plug it in. So 0.16 times 0 plus 0.44 times 0 is going to give me 0 plus 0, which is 0. Is that less than 50? It is. It makes the inequality true, so that means that point is in the shaded region. So everything under the line gets shaded. Okay? So now it's asking me for what are 3 possible solutions, okay? Guys, so we said that X was our US calls and Y was our Mexico calls. Can't we really pick anything? We can pick any coordinate point that's on there. So 150, 30. X is 150, Y is 30. Is that it? That would be in the shaded region. So I'd like you to pick 2 additional points and let's talk about them tomorrow in class and see if they are reasonable solutions to this inequality. So let me walk you through what we did again. We looked at our equation. We wrote an equation in 2 variables. We used less than or equal to because the maximum amount of our card was $50. We graphed it, the inequality. We used a test point like we had on the previous ones, and we realized that there are all these solutions that we could find. So many different ways that we could make calls between the US and Mexico and be less than our $50, less than or equal to our $50. So I'd like you again to find 2 other possible values that would make sense for this in a real life situation, okay? All right, and that's it. So I will see you guys tomorrow, and we're going to be practicing inequalities, systems of equations, and a little bit more of chapter 2 on piecewise functions and absolute value, okay? All right, see you tomorrow. Bye.